So this whole exercise is having the moles question from maybe the past 10-year moles questions are there in this whole exercise, or maybe more than that. So it based on the practice, like more practice you will have related to this moles topic, better understanding you have. So it's not like we'll try to complete this whole exercise in one day. We will do a question or two in every session or alternate sessions so that you will remember how to solve these questions, or you will learn the pattern, how it can be done. So first question is related to empirical formula of the compound. As we discuss how to work out the empirical formula, the step one, you will divide by atomic mass, relative atomic mass. Step two, you divide it by the smallest value in the combination. And step three, you will make the simplest ratio in a whole number. And I want participation from everyone. So first we have hydrogen is there, phosphorus is there, and oxygen. So we have 3.66 hydrogen, we have 37.80 oxygen, and phosphorus, and we have 58.54 oxygen. What's the first step? The first step is divided by atomic mass. What is the atomic mass of hydrogen? You can use a periodic table. What's the atomic mass of hydrogen? You can use chat, you can use mic. Hydrogen is 1. What about phosphorus? What's the atomic mass of phosphorus? Right, 31. And what is the atomic mass of oxygen? That is 16. So 3.6 divided by 1. So it won't make a difference. It will be same. So this will be 3.66. Then 37.80 divided by 31. What's the answer? 1.219. Okay. So this is 1.219. And 58.54 divided by 16. What's the answer? 3.65. 3.658. The second step is divide by the smallest value in the combination. So which is the smallest value in the combination? We have 1.219. Don't round off the values. Don't round off. So 1.219. And try to solve these questions with me so that once we finish the session, I will ask to send the pictures of questions we have solved today session. So you have to send it once we are done. Like if we finish from page 1 to 10, so you have to send the picture from 1 to 10. So it's better you solve during the session. So 3.66 divided by 1.29. So this will be 3, this will be 1, and this is also 3. So what is the empirical formula of the compound? It shows like the compound should have, when we solve this is about 3 is there, this is 1, and this is 3. So the empirical formula of the compound is H3PO3. Is it clear? This one, anyone having a doubt or a question? In the next question, a compound Y. So there's another compound, like there's no relation with the first part with the second part. It's totally independent. So there's another compound Y which is have an empirical formula of H3PO4 and the relative molecular mass is 98. Deduce the molecular formula. So how we can work out the molecular formula? The molecular formula is empirical formula times the molecular mass over empirical mass. So molecular formula we are finding, the empirical formula of the compound is H3PO4 times the molecular mass. So what is the molecular mass? That's given 98. And what about the empirical mass? Empirical mass you will get from empirical formula. So this is empirical formula. You can get the empirical mass from this formula. So what is hydrogen? Hydrogen is 1 and there are 3. So 1 multiplied by 3. What is phosphorus? You will use a periodic table. It is 31. And what is oxygen? It will be 16 multiplied by 4. So 16 multiplied by 4. So 64 plus 31. So it will make 95 plus 3, 98. So the total mass, empirical mass is also equals to 98. So 98 divided by 98, which is 1. So means H3PO4 is multiplied by 1. So it won't make any difference. So the molecular formula will be same as the empirical formula. So if we have a compound which is having a same molecular mass and empirical masses are same, it means that it has the same molecular and empirical formula. So it will be H3PO4. Is it clear, this question? Moving on to the questions related to the moles. So three formulas you have to remember as we discussed in the beginning of the session, that moles equal mass in gram over molar mass, moles equal volume of a gas in decimeter cube divided by 24, and moles equal concentration times volume. So in this question, sulfuric acid and potassium hydroxide are reacting and it is forming potassium sulfate and water molecule. It's better by looking at the units, you should identify what quantity is given. So calculate, the question is calculate the volume of 0.0625 mole per dm cube of sulfuric acid. So mole per dm cube is a unit of the concentration. So we have the concentration given of sulfuric acid. That completely reacted with 25 cm cube. So 25 cm cube is a volume and 0.1 mole per dm cube of potassium hydroxide. So this is also a concentration, but this is a concentration of potassium hydroxide. The first step, use when moles questions are there, usually they give you the step. It's a rare that steps are not given in the direct, they ask the question. Usually the steps are there and you follow the step, you will get the final answer. So the first, they ask calculate the number of moles of KOH, potassium hydroxide, in 25 cm cube. So we have the volume in 0.1 mole per dm cube, the concentration. So I have the volume and I have the concentration. Which formula I should use? If I have the volume and concentration, first, second, or third? If we have volume and concentration. I have the volume and concentration both. And the second formula is only valid if we have a volume of gas. Potassium hydroxide or sulfuric acid, these are aqueous, they are solution. So for solution, you cannot use the second formula. Second formula is only valid for gases. So we have to use the third formula as we have the volume of a solution like hydroxide, alkali. So we have the volume of the solution and we have the concentration of the solution. The moles is denoted by N and it is concentration time volume. The concentration is 0.1. And what about the volume? The volume is always usually given in cm cube. So you have to convert into dm cube. So how to convert the cm cube into dm cube? You have to divide by 1000. So 25 divided by 1000, it will be 0.025. So this will be 0.025. So when we multiply both of them, 0.1 multiplied by 0.025, it will be 0.0025. So answer here, that is 0.0025. Is it clear? The first part which we use and solve by using a formula. Anybody having a doubt or a question in this? They asked to calculate the volume of sulfuric acid. That is the last part. Like whenever you're solving a moles question, you always follow the sequence. So the question finding the volume of a sulfuric acid is actually the last part. Calculate the volume here. So you have to follow the step to reach the last part. So in the first one, we have to calculate the number of moles of KOH. So we have the moles. So this is the final question. Volume of sulfuric acid is a final question. But to reach this, you have to follow the steps. So what are the steps here? The first one, calculate the moles of KOH. And you have the volume and you have the concentration. So if we need the moles is concentration time volume. The concentration is 0.1. And what about the volume? The volume is 25, but that is 25 cm cube. The volume must be in dm cube, so that's why we divide by 1000. So 25 divided by 1000, we got 0.025. When it is divided by 1000, we get in dm cube. And when we multiply, the final answer will be 0.0025 moles. Now, so for a moles question, as I mentioned, there is a pattern. The first part we solve by using a formula. The second part we'll solve by using a ratio. But what ratio we will take? For ratio, we need the equation, and what ratio we will take? We'll take a ratio between the quantity which we calculate in the previous part, we calculate KOH, and the quantity which we need now. So we need the moles of sulfuric acid. We need the moles of sulfuric acid, and we have the moles of KOH. So for ratio, you have to use the equation. How many moles of KOH are there in the equation? When you check equation, how many moles are there? So there are, this number is representing the mole number. So according to equation, the QH is 2. And how many moles of sulfuric acid? 1. So when we write the ratio between H2SO4 and KOH, so according to equation, if we have 1 mole of sulfuric acid, we should have 2 moles of KOH. So the ratio between them is 1:2. But in the question, we don't have 1 mole. How many moles we have for QH? We have the moles of QH is 0.0025. So we have 0.0025. So how many moles of sulfuric acid should be there? X. So first part we solve by using a formula. The second part we solve by using a ratio. And what ratio we are taking? We are taking a ratio between the quantity which we have in the previous part and the quantity which we need now. So we are taking a ratio between sulfuric acid and potassium hydroxide. Now to take a ratio, we cross multiply. So 0.0025 will be multiplied there and X is multiplied with 2. So this will become, now you have to solve. So this will be 2X is equals to 0.0025. If you need X, it will be 0.0025 divided by 2. So 0.0025 divided by 2, what we will get? We get 0.00125. Okay. So we'll get the final answer here, 0.000125. 125. Is it clear? The second step, how we got the moles of sulfuric acid? Anyone having a doubt or a question in this? So whenever we are solving the moles question, we always follow a sequence. It's formula ratio. Then the third part is also by formula. And now which formula we will use, it depends on what we have. If you see what we have for sulfuric acid, we have the moles of sulfuric acid because these are the moles that we have for sulfuric acid. And we have the concentration of sulfuric acid in the beginning of the question. H2SO4 concentration is also given to us. So if I need the volume, so again I will use the third formula. If I need the volume, again I will use the third formula. The third formula is the moles equal concentration into volume. We have the moles of sulfuric acid. This was 0.00125. So we have the moles of sulfuric acid, so 0.00125. The concentration of sulfuric acid is given in the beginning of the question, start of the question. It was 0.0625. So this was 0.0625. And the volume we don't know. So if I need the volume, this will go there in division. So this will be 0.00125 divided by 0.0625. We'll get the volume, but that volume will be in decimeter cube because whenever you use the formula gives you answer in dm cube. But the final answer must be in cm cube as it is given. So when 0.00125 divided by 0.0625, what's the answer? When we divide them, 0.02. Okay. So we have 0.02 dm cube. But in the question, the final answer, it is in cm cube. So we have to convert the dm cube into cm cube. So if you want to convert the dm cube into cm cube, this time we'll multiply by 1000. So when we multiply by 1000, what will be our final answer? The final answer will be 20. So if you see the pattern of the question, the first we solve by using a formula, the second one we solve by using a ratio, and the third one so for the third one, we again use a formula. So it's a sequence like formula, ratio, formula. Which formula to use depending on the question. Sometime you have the mass, you will use the first formula. Sometime you have the volume, and sometime you have the concentration or the moles, you'll use a third formula. Is it clear, this question? The last part and the first two as well. So moving on to question 3. So about a minute left, so I'll share another link and we'll discuss question 3.